Let's turn back time to 1972 as I enter Butler University as a physics major. Now, this is kind of a mistake because I basically was interested in two things: music, that I thought would be my career as a trumpet player, which turned out not to be true. I found that out very early. And the other was electricity, electronics, electrical engineering. But here I am at Butler University that doesn't offer electrical engineering, so I end up in the physics class. Am I going to have to transfer schools? What's going to happen? Well, let me give you a flavor of my physics class. Now, it's taught by a professor that assumes you've had some calculus, so at least it was intriguing to me. And what you see here is Newton's first law with a bunch of this garbage. How come you just don't say a position in motion stays in motion, position at rest stays at rest? No. That's not good enough. No, we're going to have to use the second derivative of position with respect to time is 0. And that's true if the net force is 0. So if there's no net force, then the acceleration is 0, meaning velocity is a constant, or you're done flat 0, moving at all. So you have to put a net force on it, or you're not going to move any place or move any faster or go any slower. Okay, giving you the flavor for differentials. Now let's go down to the most famous one. The second law. What do you rattle off? You say F equals ma, force equals mass times acceleration. But not so fast. Let's find out what really it looks like. What did Newton intend? Well, if we come up here, if I can position this correctly, this is one form of it, but this is the form that Newton said. He was more focused on momentum rather than mass. So, and this turns out to be great for quantum mechanics. So, the first derivative of, with respect to time, of momentum is equal to the force. So, you put a force and momentum changes. So, see what I mean? It's a little bit different. And so I knew, hey, I'm getting the real stuff. So maybe I can figure out about electricity. Maybe I can understand how static charge works, or magnetism, or all those kinds of things. But this is just the general physics course. Now, if we want to get down to the third law, which we should do to polish this off, let me scroll down here. Here's the third law. And this little dot means it's really the velocity, means that the momentums with respect to time all add up to be 0. So if you got a momentum in one direction, you're going to have momentum in the other direction, and all these fancy symbols to say a reaction creates or a force causes a reaction, action a reaction, and you know what I'm talking about. Anyway, that's what that is. One day I was eating lunch in the cafeteria, and the professor comes up and joins me at the table, and we get into a conversation, and I talk about my background and so on like that, and he says, well, what you ought to do is immediately go into electrical measurements. You can do your course work for the first course in classical physics, but you can also do electrical measurements. And I'll kind of shave the corners so that we can tailor your experience here at Butler to be electrical engineering. And this was groundbreaking because this meant, hey, I don't have to transfer, and I can stay here at Butler, and it's a good deal, believe it. Remember that self-help book, that self-guided thing where you don't need any math and you can figure stuff out, but you're not really sure, it's kind of a mystery? Well, in electrical measurements, it's a little bit different. We have this book. Here's the book. Basic Electronics for Scientists. Whoa, scientist. Am I a scientist now? This book is written at a high level, and I can study it even today and learn more and more. So this was seemingly just a background for physics people to understand electronics, but it is a great book. And later on, remember this is 1972, the transistor has only been around just a few years, and this is digital electronics. It gets into gates and all those things so that we can start talking about computers. So all of these things are running around as I go through this course, which is self-guided, by the way. The professor pops in and says, "How are you doing? What are you doing? Okay, that's great. Keep it up. Don't forget about your main physics course to keep track on that." In a separate class, I'm taking computer programming, not in the math department, but in the business department, because that teacher was a lot more fun. Fortran program that was reproduced by AI is very similar to one that I did, a program to calculate series and parallel calculations. So let's kind of walk through this little window here and see what we can find. Here's the program name, series par, which is like parallel. And here's a comment, resistor calculations. Then we have to define the variables. Real is R1, R2, RS for our series, and RP for our parallel. Then we need to know what the format is. So that shows up down here, enter R1 and R2, and then it shows that 100 and 200 were the values that were entered. Here's my card deck, very short card deck, which I have to punch out on a little punch card machine. And then I put these IBM cards up to the window, and then the operator loads them in there and runs it. So let's see what the outputs were. Well, it shows that enter R1 and R2. Here's the two values entered. Here's the output, 366.67. So everybody in the programming class puts their little decks in there, and if there's an error in your job control cards and it screws up, you got to go to the end of it. And the turnaround time was about 45 minutes. So you could usually, if you made a lot of mistakes, you're going to be down there at that computer window for a long time. So there's a big gap between how that computer worked and my electronics course. So that was the gap that I couldn't figure out how to fill in. Something happened second semester, close to the end of the second semester. I don't really recall the month, but nothing made sense to me. So what happened? Well, I dropped out and I didn't know what I was going to do. And that's the next chapter of this story.